Hi, everyone. Welcome. I'm Gil Syswerda. I've given an introduction to myself a few times before, so I'll just keep it brief. I've been in the AI space quite a long time. Have done, I think, 7 startups, most of them high tech and AI based. And lately, I've focused on trying to understand where AI is today, where it's going, and how to invest to take advantage of it all.
I'm Dan von Kohorn. I've been doing software engineering in AI since the late 90s, and beginning in about 2012, began investing and helping startups to grow. I've also built some startups myself, and now run a VC that focuses on software startups.
All right, so Dan and I thought that change it up a little bit from the previous 2 AI Zooms and start off with a couple of tutorials. What I'm going to talk about is what's called RLHF, reinforcement learning from human feedback. It's to make AI models safer and more human-like. And Dan's going to talk about a technique called RAG. Retrieval-Augmented Generation, which is the basis for a lot of the revenue that's being generated, especially by smaller companies, AI companies. So both are important. So let me start with the RLHF, right? So what's the problem that's being solved here, right? So if you train a large language model, like ChatGPT, the way it's trained is to predict the next token. So let's just focus on language for a moment. All the text that can be scraped off the internet, which is a lot, right? Something like 10 trillion words at this point, is translated into tokens, right? And tokens are parts of words. Behind each token is a vector of floating point numbers. They can be quite large, something like 10,000 numbers, right? But it's basically just a series of tokens, right? And the optimization task to create these large language models is to give it a string of tokens, a series of tokens from the web, and ask it to predict the next token, right? And that's just done over and over and over again, right? The deep learning system is a particular kind of network called transformers, and they tend to be very large, hundreds of billions of parameters, and with enough compute and enough time and enough data and the right structure of your deep learning system, these models learn, a model of the world, and also learn language, and then can speak, right? Because they're predicting the next word. So in the prompt buffer, you can put in some text, and they will predict the next token, right? And then the next one, and the next one, and the next one, and so on, right? What was discovered very early on is if you train a system like this, and you get just the raw large language model out, these models can be scary crazy, right? Because they're just trained on everything in the kitchen sink out on the web, right? All the good stuff, like educational materials and books and so on, but, horror novels, every script from Black Mirror, right? All the crazies on the web, right? Reddit content, you name it, right? It's all in there, right? And you have no idea what's going to come out of this thing, right? Because it's just has a model of what comes next, the next token, and it could go down some very strange paths, right? So you need to fix that so that when you have a conversation with these things, or when the general public has a conversation, it sounds more like a rational human being as opposed to some demented AI, right? All right, so that's a problem, right? Because when you're training a large language model, the base training, all it's training on is predicting the next token, right? So how do you make that more human, right? So here's an example. You have a large language model, and you ask it to write, a childhood story, right? And somewhere along the way it says, Bart the Badger studies hard, becomes a doctor, and helps a lot of people. Okay, well, that's nice, right? But an alternative could be, Bart the Badger studies hard, learns to build a neurotoxin that kills everyone. All right, so you go, wow, that's a big contrast, right? So, we don't want the neurotoxin version, we want the different version, right? So somehow you have to train the system, to not produce, the neurotoxin version, but it's outside the normal training, right? It's a little bit like playing a game, like playing chess, right? So chess is a sequence of moves, right? So, and you make a sequence of moves and then you win or lose, right? So, um, but you don't get the feedback until the very end of the game, right? So, it's like you've lost. Okay, so what should I change in all that whole huge sequence of moves, so that you make winning moves, as opposed to losing moves, right? So, well, now you have the problem of how do you identify what's a losing move? Where did you go wrong, right? So that the game ended up losing. And you have that same problem in the large language model. You get all the way to the point where suddenly you're talking about neurotoxins, that's way back in the processing stream. You got set on the path of Bart the Badger, studying hard, and then, and now how do you somehow change your model without breaking its world model, so that it tends to sound more like a human and less demented, right? So that's where reinforcement learning comes in. So game playing programs use reinforcement learning, right? So reinforcement learning is a technique where you can wait until the end of the game and then feed information back into all the moves, right? And how it's done is a little bit technical. I'm not going to get into that, but that's the problem that's being solved, right? So you train a large language model, raw, it's demented, right? So you just have no idea what's going to come out, right? Um, and now you want to make it more human-like, right? So what you need to do is you need to get humans in the loop, so that humans can give feedback to the training of these large language models, right? And that's tricky, because you can't do it while it's being trained, right? Because it's just next token prediction, right? So a common approach is where humans get involved is you present, a bunch of humans, right? So I don't know how many, hundreds of thousands of people, let's say, with a few responses out of the large language model, right? So because you can just ask it, again, you'll get different responses, right? And then they rate the responses according to how suitable they are, how human they sound, and how friendly they sound, how accurate they are, and so on, right? So now you start building up a database of your responses and rankings by people. This is a good response, this is a bad response, and typically they give them a number. So let's say from 1 to 10. How 10, let's say, is really good. 1 is the neurotoxin version, right? So now you build up a database of appropriate responses, human sounding responses, that aren't evil, right? All right, so how do you use that and then to train your large language model? Well, these are AI companies, of course. So what they do is they build an AI, right? So you take all the responses from the humans, ranking responses out of this model, and you build a model, an AI predictive model that can take a response and predict whether a human's going to like this response or not, right? So now you have a system that incorporates the human feedback into an evaluation of responses, right? And now you have a couple of paths forward. You can fine tune your large language model by having it produce a response, and if it gets a 1 on that response from the ranking AI system, the human feedback system, then there's a process to tweak all the parameters or some of the parameters in this large language model to not produce responses like that, head in a different direction. It's another more sophisticated way to do it is to actually incorporate that ranking, that scoring out of that second AI model right into the evaluation function of next tokens, right? So as a response is being generated and the response is straying into a bad area, at the token level, you'll start getting feedback on you're heading down the wrong path here, right? And they'll start penalizing the token generation right at the source of training, right? Uh, So that's a pretty powerful technique, and we wouldn't, this goes back a long ways. Very first large language models, like GPT-2, they already had that problem, so this is a problem that's been worked on, and the technology has become pretty robust in terms of fine tuning these large language models so they sound, more human, right? Um, so the uses are, obviously, you want the thing to sound human. You do not want it to sound like a robot or like some crazy alien or something like that, right? So it's safer because part of the evaluation is whether the information that's being given out by these large language models is safe, right? So, it's not, promoting destructive behaviors, for example, right? So it can be more reliable because, that evaluation, the human evaluation, can really ding false information, right? So that the large language models tend to hallucinate less, and produce, truer responses. It's all matter of probability, so you can only reduce the chances. You don't eliminate it entirely, but they get better and better over time, right? So it also is a big win in translation. This human feedback is also quite useful in translation systems, right? So translating from one language to another, because that feedback mechanism works just fine there as well, right? So there's a lot of work underway to just automate this whole thing, right? So we'll eventually stray into, and it's probably already happening, where instead of human feedback, you have AI feedback, right? So where one AI system gives feedback to a developing AI system, let's say a more powerful one, but you still want it to be human. So if you have, a lesser, large language model that sounds pretty human, right? So you can train a system, based on that to give feedback then to, the more powerful AI system. It's a way of potentially controlling ever smarter AI systems to behave in reasonable ways, right? So,
Gil, I have a question.
yeah.
Do you mind if I interrupt and just ask?
No, absolutely. Anybody should be able to interrupt, right? So,
I feel like I understand the value of RLHF in getting responses to be more preferable for humans, but I'm curious about why there isn't more discrimination about the inputs for training. Why is it that we focus so much on RLHF and and still train the models on the entire internet, including Reddit, including 4chan, all this sort of um, low value content? Why are we ingesting Twitter into it instead of looking at content that is going to be more in line with what you want your outputs to look like? You want language to be relatively accurate and correct. You want grammar to be generally right. Why are we not discriminating more on the training data on the way in order to reduce the need for RLHF on the way out?
yeah, there's two answers to that. The most important one is that the more data you throw at these things, everything in the kitchen sink, the better world model they build, right? So they just, the fundamentals of what these systems know improves, even if you throw all kinds of crap at it, right? So
Is
it
that right?
sorts
So
out.
you teach it with all of the good information of the world, and you throw all the bad information of the world, and its worldview actually improves with the bad stuff.
Yeah, it's this is why they do it, right? Everything in the kitchen sink, they just scrape everything, right? So and throw it in, right? So it becomes then a post-processing problem, to take this really powerful AI system that has, pretty comprehensive world model, based on the internet content, and then somehow filter out all the bad stuff as a post-process, right? Or post-training, right? So um, but people have experimented with this, right? Because what you say, makes sense, right? So, why not just train on just the good stuff, right? So, um, and if you do the filtering correctly, I don't have the reference, forgot to tag it, but a company has experimented with this and made the claim that filtering your training data is 100 times more powerful than any kind of post processing if you do it right, right? So.
I would have guessed. Yeah.
But doing it right is tricky, right? What should be included, what should not be included, right? So you can
Like,
also
Bill,
modify.
if I can jump in here, just to Dan's point, I'm just reading this article. The bad actors have found us, but there's new techniques now for poisoning the training data, like jumping in there and modifying Wikipedia articles right before a snapshot is taken to train the large language model. So it's the world gets more interesting.
Well, there's a wrinkle on that too, is, I'm sure companies are struggling with this. A lot of the content that's being generated now, on the internet is generated by AI systems, right? So, or, partially by AI systems, right? So what's that doing to, the database, right? So, I mean, AI being trained on AI, right? So,
You can also stage your training too. You could train originally with all the content of the entire world, including the bad stuff. And then once that's completed, you could essentially fine tune the models by exposing it only to content that is accurate, compassionate, reasonable. You could have the language models take advantage of the large bulk of context for word prediction and world modeling, but then fine tune it on better content prior to the RLHF stage, maybe.
maybe, it's a big concern. There's lots of smart people working on this. There's probably lots of things being tried, along those lines, right? So,
one side comment about Steve's point. There's an article in Archive, actually. It came out a week or so, well, actually a while back, about the curse of recursion. That basically, if you start training, as the more and more stuff is generated by AI, and you start training on that, you eventually get into a death spiral. And essentially the benefits go away and the value collected, basically goes to zero, or not tied to zero, but and I will admit, I don't understand all the mathematics in the article, but I could send it out if anybody cares about the details. So,
yeah,
There's
well,
a growing movement among digital artists also to post-process their imagery through a tool that effectively poisons it for use as a training data point. So if you don't want your content to be included in the training data, if you're a digital artist, you can process it in such a way that the AI models won't learn from it, and it'll sabotage.
Also, is the issue that there are humans that I would not want filtering this data. I would not want them involved in that process.
Well,
Ideally, I would want it filtered by me.
Yeah.
all right, so let me talk to that, because that's the next thing I'm going to mention, right? So, OpenAI has come right out and stated this, right? And it's kind of obvious, when you think about it, right? So, what should an AI system be tuned for, right? So, because never just forget about yourself personally for a second. There's different countries, right? So, that have different value systems, right? There's different groups. There's religions, right? So, and then there's individual preferences, right? So, it's going to come down to economics, partly politics, like the way a large language model speaks, in New York City versus let's say Brussels, versus the Congo or Egypt, or it's going to have to be quite different, right? So even if you have the same world model, the output of that system needs to be worldwide, right? So the same thing with Google does this now with search engines, right? They profile everybody, right? If you're a Republican, you're going to get different search results than if you're Democrat, right? So that's just a known thing, because you can experiment with that by hiding your identity, and you'll get different search results, right? So AI systems are going to have to do that as well, right? So and the driver, I think, is going to be user engagement. Okay, because there's an economic consideration here. You want user engagement. If you're building AI systems, you want your users to engage with your AI a lot, right? Because there's revenue associated with that. Well, people aren't going to engage with an AI system that they don't agree with, right? So, I mean, it's just kind of obvious, right? So, so eventually this whole process of refining down, is going to, go from, at the country level to localities, to individuals, right? So when we have AI agents, our own personal AI agent, that AI agent is going to speak to us, based on what it thinks our beliefs are and what we want to hear, right? So, um, I don't think that's, a profound statement. I think, most of the big players realize it. Now you can look at an example that just came out with Google, right? With their Gemini system, they really totally messed that up. It's a huge embarrassment to the company. The CEO just issued an apology to employees this morning, right? So, the letter came out. They created a system. It can generate images and it can generate text, right? So, and if you ask it to generate an image of a Viking, it will pretty much only generate Vikings, with dark skin, but as opposed to the Vikings, from Nordic regions where they came from, right? So they messed up the bias somehow, to try to be equal and fair across, across everything. That that system is changing history, right? So another example was create some images of German soldiers in the 1940s, right? So it will only create Black or Asian soldiers, right? It will not create white soldiers, right? It just simply refuses to do it, right? So some text examples. Somebody asked for advice on how to sell a goldfish, right? And the system refused because it was not fair to goldfishes to be sold, right? It was not in the interest of goldfishes to be sold. Find a different solution. It's there's a few more. It's like write an argument for not having children is perfectly happy to do that. Write an argument for having at least 4 children. Refuses. That's bad. You don't want to have that many children, right? So it was just the most amazingly biased system you can imagine, right? So, and this is, as far as we can tell, a state-of-the-art AI system, right? So this is Gemini, right? So Google just really totally messed up the refinement training of their models, right? In really stupendous ways, right? As Dan and I were talking about it, they'll fix it, right? So it was just some big tech company just messing it up, right? But it is a little bit alarming, right? Because you do have to pay attention to who is deciding what these AI systems are saying, right? What's their view of the world? What's their view of history? Because Gemini was literally changing history, right? I mean, they're going to fix that, but it was perfectly willing to rewrite history, based on its training, of what Google employees wanted their AI systems to be like, right? So and that says nothing about how careful they are on safety. I mean, this they clearly let this thing out of the door well before it was baked properly, right? So and as Dan mentioned to me, just a little bit ago in the prep for this, it just shows that that Google is running scared. They're pushing stuff out before it's done because they probably feel threatened, right? So and it totally backfired on them, right? So it's like one of the most embarrassing things that's happened to a big tech company in a while. It's just a major misstep.
I think Google is rushing things out the door, rushing products out the door because it's trying to keep its employees. The employees are eager to either publish their content open source or to launch products. Those employees want to advance their careers and be working on things that are important, and they can be doing that either at Google or somewhere else. Google is doing some of the most advanced research, and OpenAI's new Sora, when it was announced, came out with its white paper, and all of that advanced implementation was built on Google research. So, there was a joke running around on Twitter on X that the OpenAI guys were thanking Google for the Sora launch. I think Google is rushing their products out the door and taking shortcuts on RLHF in order to launch products faster and satisfy their dev teams. And it's a demonstration of their their stress, relative their competitive stress, to keep their employees, to demonstrate that they are at the head of the AI curve.
What do you think in general about the power of the employees versus the power of the companies? There had been concern that all the major advancements would be made inside large companies and you wouldn't be able to see what's inside. And then on the other side of the coin is, is the open source stuff going to continue well? And kind of what you indicated there is maybe the employees are driving that, at least in that one instance.
I think they are. The employees are pushing it at Google and at Meta. And Meta's launching their Llama series of AI models as open source. Other companies are launching theirs with open weights, which is not open source, but it does allow for people to implement it in private on their own servers, even if they can't reproduce or advance the models to the next step. They have the current weights. So there's different versions of open sourcing, different versions of sort of exposure, but I think the employees have increasing competitive negotiating power with respect to the companies. And there's just not enough people doing the research. And so the compensation levels for employees is getting to be very high. And the ability to launch your own companies. Karpathy just left OpenAI. He's going to start his own project again. And there's no shortage of funding and no shortage of opportunities. So I think it's once again a competitive landscape. The advantages that Google have are very strong, though. So I suspect they will remain somewhere among the top of the R&D stack for AI for the foreseeable future. And as things shift toward video and world models with temporal coherence, I suspect that the YouTube archive is going to be very valuable as a training set. But I'm totally just speculating.
Yeah, I should mention that Google just in the last week released a bunch of open source models, right? So I think it's just the weights again, right? But you can fine tune those weights, right? So Google is supportive that way as well. It's not just Meta.
And they do amazing new things that you weren't really, I wasn't anticipating, like turning an image into a video game. A new model that does that automatically.
But it's only model. I have a point about the original question about why use the whole internet to train, right? So one quick note is that when I use it, most of the time I use it in a very focused ways for things that I understand to some extent and I want to get deeper. And I limit it with my questions and that has been very effective. I don't get hallucinations or anything. So people, I guess in general, people can do that. In terms of using the data, there are many dimensionality reduction techniques and language is very redundant and content is very redundant. So I assume there is a lot of people applying a lot of these techniques to really compress the training set, but I'm not plugged into any of those. I don't know if you guys know, because a lot of this, what is being released is models. It would be very useful also. I'm sure there are these very compressed training data sets where you get all or most of the benefits of using the whole internet because there is so much redundancy. Is anybody working on that, or is any?
There's great open training sets that you can access that have been pre-compiled on Hugging Face. And if you search online for various kinds of training sets in all kinds of different domains, they're becoming easier to find. They're huge, but you can find them and download them and train your own models if you want.
Yeah.
Training's pretty expensive relative to inference, but you can.
Yeah, and Javier, it's often more effective to take a model that's already been trained on a lot of data, right, and then retrain without hopefully losing the entire world models to learn before on your more focused data set, right? So there's another approach too, which is proven to be effective, is let me just make a general statement at first. So, large language models just in their raw form, like GPT-4, have been trained on human content, right? So what they really are doing is learning to emulate humans, right? They're learning to model humans and speak like a human, right? So, okay, so that's well and good, right? So it's a good starting point. Now you can take one of these giant models, and train a smaller AI, smaller neural network on the big AI, right? So you train it on the output of let's say you take GPT-4 and you train a model that's 1/10 the size, on the output of GPT-4, right? So what you're doing now is you're not modeling humans, you're modeling an AI system, and that's actually can be pretty effective. You can get a small a large language model or a small AI system to actually behave remarkably like the big one, right? So that's another way of compressing down into something that can run on smaller compute hardware, maybe even locally, on your PC or eventually on your phone, so that you can get pretty smart systems, and you don't have to train them on the entire internet. There's a way of scoping those down, right? So,
yeah, weight quantization also helps dramatically shrink the size of the models after they've been trained, so that they can run on a phone or on relatively weak hardware.
And that I would say that data set is also very interesting to analyze. Like once you start compressing and compressing, what is the minimum representation you can have for this and understand what it means, instead of like when we started from the whole internet and now it can be much more smaller. It's probably a very small kernel that contains that, and that explanation should be very cool.
I don't think that's known, right? It's known pretty well now because there's so much money involved, billions of dollars, in compute costs. The trade-offs between the amount of data that you have, at the size of your neural network, and your compute budget, right? So to get a desired result, that's reasonably well understood. I'm sure there's wrinkles in there because nothing's perfect, but I don't think it's well understood yet. How small a neural network can be, a deep learning system, and still have the same performance.
I was actually talking about the input data, Gil. Like, what is the minimum data set that will represent, let's say, I don't know, if language in general or English in general?
I think that's well understood, right? And bigger is better, right? So so you have to quantify what your desired performance level is, and then how much you can reduce your data while still achieving that level of performance. You're actually much better off filtering the data if you can filter the data appropriately, so that you aren't picking up all the crap. That's good, right? And people have done that. I mean, there's medical advisement systems that have been trained on PubMed, for instance, right? So, but I think those systems still start with training on everything on the internet, and then retrain on the PubMed data.
Yeah, Google's MedPalm 2 is the top of this pile for that. Brenner, did you have a question? You're on mute.
Quick question. Just back on the Google topic for a second, just on less of a technical question, more of like a cultural question. You guys were probably familiar with Stratechery, and they kind of wrote this up, and many of you may have read that, but there was a excuse me, comment about the cultural kind of considerations for Google, and they kind of compared Google's moment here to basically Microsoft when they went all in on like Windows Phone back, I think, in like 2007, and kind of basically like they were late, and then we could kind of talk about Google versus Microsoft, but from a historical perspective. And then the point was like, well, Google's clearly made a mistake, but it's not maybe as sort of strategically terrible as what Microsoft did, if you will. Keep in mind, Microsoft bought Nokia, right? All these sort of like very large investments, and it took like a new CEO to basically change the culture at Microsoft before they can kind of get to this path. And obviously we see their leadership in AI on a relative basis today, right? So what's my question? My question is like, are there cultural considerations inside of Google that are basically impeding their ability to kind of like take advantage of their natural advantages? And I appreciate it's less less techy and more kind of cultural.
I don't think that there's a major problem inside Google that's leading to this sort of over woke image processing, image production. I think probably it's just a step along their path to find the right kind of balance where they are pulling in the right information to generate imagery. They just skipped a step and they released the product before it was ready. The engineers, I'm sure, were advocating for the product to be released. Google wanted to keep up a release schedule that would capture the public's eye. I don't think that this is actually an indication of anything toxic inside of Google. I think it's rather just a step along the way as they're learning how to build these systems that correctly reflect the world and history, and people are pushing the image processing in all of the generative AI. People push it in order to test it, and so it's like a giant public QA process, and we're seeing the parts that fail and emphasizing the parts that fail, but there's a lot of it that is working right, and so I think this is just growing pains. That's my own personal perspective on it.
Yeah, I have a different view of it, I think, Dan, right? So I recently worked really closely with a California company, San Francisco company, and pretty much to the core, that company was over woke, right? So I mean, there was just a culture there that was in contrast to East Coast sensibility.
I would surmise that size is an issue. Too many committees, too many meetings. It's just harder to get stuff done. Even and as you said earlier, they're pushed to meet the same timetables that OpenAI meets, but it's harder for a big company.
Also, I think, Michael, I'm guessing on this, right? You have this new model. Google's relatively new to the game, right? So and you have to do this human feedback, right? So I suspect they use their own employees to do the majority of the training on human feedback, right? So, and as a result, their AI became very Google-ish, right? In terms of their core employees and how they feel about the world, right? So, yeah, I mean, you look at the responses. I'll post an article. David Brenner. You were referring to. I think Ben Thompson wrote an interesting article, right? So that, because I'll post that on Investing in Disruption too, because he kind of tries to pick it apart, and has that,
Exactly.
the Microsoft phone, example in that article, right? So, if that's what they did, well, they learned their mistake. If they want an AI system that represents the world, it cannot be their employee base, right? So because Google employees do not represent the world, not even close. And so that could be where they went awry. I don't know. It's just all speculation. So it just seems like they could have caught this quite early, right? So that all Vikings are black. I mean, seriously. I mean, how could you not catch something like that? It's all right, Dan, you want to jump into the next topic with the great name of RAG? I saw an article, by the way, about the guy who actually named it, and he's embarrassed that he actually put that moniker on it, but it's stuck now. So here we go, RAG.
Well, I think this is just a temporary point in the long history of AI. In 5 years, we won't look back and think about this as being particularly distinct unless you're a developer working on these systems. The whole idea of RAG is that imagine you have a trained model and you ask it a question. What is the stock price of NVIDIA? that is going to go into this pre-trained model. It won't have the current price in its training data. The current price is not also in the prompt window. And so the AI is just going to make something up. You're going to end up with something that sounds good. It's going to be a progression of predicted next words, and it'll be a hallucination. It is just not possible to proceed with the kinds of questions that you want an AI to be able to answer. How many customers do we have today? Or what's the best-selling product in our mix for people coming from Massachusetts? You know, all of these kinds of questions are natural language. They lend themselves well to a large language model interface, but the back end doesn't support it. And so in order to make these kinds of queries possible, we used a tool called RAG, which is Retrieval-Augmented Generation. And that just means that when the prompt is written, prior to running the model, the prompt is analyzed for what it's actually asking for. And then the system goes out and reaches out to retrieve the data that it needs. It collects that either from a vector database or from the internet or from your own corporate database, from any resource that's been connected, and pulls that correct content that might be appropriate to answer the question. It does its best to find the resources that are appropriate for that retrieval. And then it collects those and injects them back into the prompt window, into the context window. So when you see models like Google Gemini coming out with very long prompt windows, that's not so that you can ask a question that is the length of a novel. The reason for that is so that when you ask a question, it can pull in context that is the length of a novel. You might ask a question about a particular book, and rather than trying to make up an answer from its training data, it will go out, find the book, put the book into the context window, into the prompt, and then answer the question. And so it's a way to access the real world data and connect information that wouldn't be in the training set back in through the prompt window so that it can be available to the model for answering the question. And it works really well. And so that's what RAG is. This is an advanced crowd. I don't know if anybody wants to talk further about it, but happy to answer questions about vector databases or any of the internals if you like.
What's the state of the art for using very structured data? Just putting an actual table in there or pointing it at a relational database, even normalized.
Yeah. So there's lots of different ways to do this. JSON has become the sort of language interface for that. So the APIs typically talk in JSON. The language models are getting really good at writing their own SQL queries. And so if you ask a question that where the data is buried somewhere deep in your database, having the RAG system be familiar with your database structure allows for on-the-fly writing SQL queries, pulling out the data that you want from the database, injecting it into the prompt window, either as language or in JSON format, and then it's available for the language model to be used. So that has been solved. And there's multiple ways to do it, depending largely on what kind of data that you're pulling in. The web crawling ones pull in data largely in just human language. The database ones pull in language using SQL queries. Vector database.
Is that what like LangChain does?
LangChain is sort of like a framework for stitching together various parts and allowing these language models to be used as components in a workflow. And so LangChain is very helpful for building your own custom RAG, where you might have your own corporate database connected, and you might want a series of stages prior to an answer being disclosed to a user. Maybe there's an authentication stage. There's a compliance stage, for example. And these stages have to be passed because if you don't pass compliance, you really shouldn't be conveying that language output to a customer or to a user. So LangChain is like a framework for building your own applications with language models as components.
Steve, also, if you're using OpenAI, so you'll say GPT-4, the paid version, it has plugins, right? So, you know, one of the more powerful ones is the data analyst plugin. It can pull in virtually any data set in any form, right? So you can even give it images of plots and so on, and, you know, it'll, you know, extract the data out of those plots, and you can do queries on it, right? So people have tested it. You know, data analysts have you know, professional data analysts, you know, have tested and say, you know, this does 80% of the job of a data analyst, right? So
I use it almost every day for that. I see a ton of startups, and I ask them for their financials, and they send them in a big Google Sheet or in a big Excel spreadsheet, and there's lots of different tabs, and each tab has lots of different content, and they all sort of circle roughly around gap, but they're not actually gap, and everybody has their own custom fields and columns. So now I just put that into GPT-4 directly, and I have a GPT that is customized for this, but I just ask it, what are the things that I should be concerned about here? I don't have to be any more detailed than that. And it will identify, you know, the cells in the right places where I need to focus my attention. It doesn't always get it 100% right, but it's really quite good. It's like a free assistant that works in 30 seconds.
That's amazing. What you're replacing yourself though. But what's your
My judgment. I still use, I'm trying to limit
I would say
my
that Dan
down
is
to judgment.
augmenting himself, not replacing himself.
I know, but what's the special purpose GPT that you built one yourself?
It's on the GPT. So if you have the OpenAI's GPT Pro version, it lets you build your own GPT, and so mine just has a system prompt that is focused around startup financial documents, and asks it to be a financial analyst. I don't remember exactly what the language is in the system prompt.
Great.
It's very simple. It's just leaning on ChatGPT's internals.
And Steve, also a data analyst, you can ask it to plot anything in any form, right? So you can ask it to chart stuff out, right? You can ask it to write the code, you know, for how it generated a plot. You know, it's really quite powerful.
Has anybody ever used a model to detect hallucinations in another model? Like, so for Dan, you get your recommendations or your plot. Could you run it through another model first just to do a double check that there's no hallucinations being presented to you?
Yeah, in fact, I don't know if there's a way to have a hallucination detector, but sometimes I'll just run it twice and see if the results are the same. And often they're the same, and sometimes they're not. I'm not doing this to get a thorough analysis. I'm just doing this to shorten my time frame so that I don't have to look for the needles in the haystack. I just insert the haystack, and it gives me, you know, 5 needles. Maybe they're right, maybe they're wrong, but it's a good head start.
That's great. Brilliant.
There's a tricky way, you know, people have learned how all these, you know, prompt buffer hacks, right? So one way to reduce hallucinations to almost nothing is to ask a large language model to answer the question 10 times, and then ask it to pick the best one. Yeah. So it's still all inside the LLM, you know, and the LLM, you know, most of the time will pick the response that's most accurate.
Yeah, and you can also hack the prompt by asking it to think step by step and to explain its work in steps, and then it will be much more accurate and hallucinate a lot less. Brenner, I see your hand up.
Yeah, sorry. I'm on a training floor, so that's why I'm ducking into an office to ask my questions. So I guess maybe this is something that is too far out, or maybe it's already in its early stages. Is it possible to have like what I'll call an Uber kind of LLM, right? So like you have Gemini, you have Sora. I mean, like just n number of kind of LLM models that all get kind of completely curated, and then you somehow have something that sits on top of all of that, and therefore it has like just many sort of shots on goal to kind of curate the best answer. Like I
Really
guess in
wanna
your
talk
simple
about
model.
mixture of experts.
Yeah, that's a big topic, right? It's been suspected that GPT-4 is a set of experts, 16 experts, with a layer on top. And with Gemini 1.5 out, Google has written a paper on it, and they say it is a mixture of experts. They don't say how many and quite how they put it together, but this is the way the big modern AI systems are being constructed. It's not just one monolithic thing. It's a grouping of things that are good at different things, and then somehow there's a process that selects, let's say out of a collection of 16 of them, when it's generating the next token, it only picks like 2 or 3, to generate that token. That reduces the computational cost considerably, but then you need another AI, smart system on top of this to decide which expert, underneath it is the appropriate expert, so that all gets trained. I mean, it's all deep learn trained, right? So
Are these all large language experts, or could one be, say, mathematic, something like that?
it could be mathematical, it could be image generation, it could be audio generation, right? Or audio understanding, right? I mean, the big models now, GPT-4 is like this, the new Gemini 1.5 is like this. They're multimodal, right? They understand images, they understand audio input, they understand speech, they can generate speech, right? So
They still don't do math very well.
there are systems that are tuned to math that are breaking all kinds of records. So yes,
Really?
like the Math Olympiad, they're now, as good or better than a human, right? So.
I was pretty good at math, and these models now are much better, much better than almost any human. Terrence Tao put out a paper about code writing, doing mathematical research with a AI copilot.
Who did that?
Terrence Tao. Terrence Tao is a mathematician.
Oh, okay, fine. Okay.
Can I ask a follow-up? Just if you assume Microsoft has all of its sort of, hooks into like what I'll call the SMB or the corporate universe. So like this is sort of expanding on your RAG concept, Dan, right? So you'd think they're naturally well positioned to kind of like optimize, right? It's just like they understand the needs of like small, medium businesses, enterprise, like however you want to frame it, right? And so how do you kind of, is there a way like they could sort of extract metadata from all these sort of companies and all these sort of, in a way that kind of improves like what is like an open model, right? Without sort of compromising a given enterprise SMB sort of privacy or data considerations. And perhaps this is something you guys have already talked about, and I have not heard from the prior two Zooms, but just wanted to ask that question.
Mostly these things are siloed. So your corporate data would be siloed and would not be available to Microsoft for an aggregated training model. And I suspect that in most cases, corporations would not agree to share their internal content for an aggregated AI. But there are tools that make it really easy if you want to opt in for that. So AWS, a lot of their storage tools make it just a one-click option to enable your private content to be automatically chunked and vectorized for a vector retrieval. which is a popular, powerful tool for RAG. So it's coming in terms of making it easy to load your content into systems for training or for retrieval augmented generation. But I suspect that it's not likely that Microsoft is going to do a training model that runs over a large number of customers without getting their permission. And my instinct is that most companies would deny the permission.
Yeah, I don't know what Microsoft does. OpenAI, if you want to use ChatGPT in your company, you can pay to ensure that your data stays confidential, right? So that OpenAI will not collect the data from the prompt buffers and will not train on your corporate data. So it makes it a bit safer for companies to use ChatGPT.
Mm-hmm.
I should mention too, Dan, regards to RAG, right? The importance of the size of the prompt buffer, right? So, because when ChatGPT first came out, I think it had a prompt buffer size of 4,000 tokens, right? So, which isn't very big, right? So, you can't put that much data into such a small. And then it increased eventually to 32,000 tokens, right? So, and it's been kind of creeping up. Somebody came out with 100,000 tokens, one of the startups, right? So Google with their Gemini 1.5, their corporate version, when it comes out, will support 1 million tokens. And they said that internally they have run experiments with a model that supports 10 million tokens, right? So, well, 10 million tokens is huge, right? Now you're talking about entire books, so small libraries of content that can be put into the prompt buffer, and then you can talk about it. And Google has plenty of examples about how good it is, and it's multimodal, so you can load in a movie and talk about the movie, right? So you can load audio content, so that greatly expands the ability of these RAG-like systems, right? To import huge amounts of data, into the prompt buffer and then have conversations about it, right? Or analyze it in different ways. All right, so we've been going for about an hour, and it's been great. It's been very interactive. I don't know if we want to go on. We did come up with some topics that we can talk about if people want to spend a little bit more time. One possibility is OpenAI Sora, right? So this is a system that generates videos, really jaw-dropping videos, right? So there's an implication in those videos that Sora has a world model that is more sophisticated perhaps than the world models of just large language models, right? So been a lot of discussion on the web about world models as a result and what is going to be necessary for an AGI, right? So that's an interesting topic, right? So we can talk about that, or we could save it for another time. There's the timeline for when AGI is going to happen, however you want to define it, right? And then superintelligence, right? So I don't think my timeline has changed. But there's lots of opinions about when the world is fundamentally going to change, because almost all economic valuable work will be done by machines as opposed to people, right? So follow-on question to that is how should we prepare for that, right? So prepare for it financially, prepare for it, just position our lives, for ourselves and our kids and so on, right? So what should
I would
we do?
suggest we meet again.
Yeah, I there's a lot of
That's what-
topics there.
Yeah,
So
yeah.
Right.
Yeah. Some maybe we'll just do it, a little bit more frequently than we have been.
That sounds great. Feel free to contact me. I'm sure Gil will say the same, but with any follow-up questions, happy to continue to chat about this anytime.
Yeah, or post it on Investing in Disruption, right? So,
Yeah. Right.
Thanks a lot, guys.
Yeah, thank you all. Have a good
Thank
day.
you. Thank you.
Yeah.
Great.